மைக் ஒர்க் ஆகுதுன்னு நினைக்கிறேன். கலரில் காமிக்குது மைக்கு. செக் பண்ணி பார்க்குறேன். சரிங்க சார், டிஸ்கனெக்ட் பண்ணி. Am I audible? Am I audible? Let me share my screen. So I have shared my screen. Please do reply in chat. Am I audible? Anyone there? Am I audible? Do reply in chat. Am I audible? Do reply in chat. Am I audible? Okay. Okay, fine. Let's start. So the question which we were discussing earlier was this. So it's an statement. Given an integer array of size n, ask us to find the count of elements whose values greater than all of its prior elements. So prior elements means previous elements. So when a given array of size n, you need to find the number of elements whose elements is greater than its previous elements. So for 7, 4, 2, 8, 9, these are the index values. For 0th index, there is no to check. Obviously, 0 would be a valid one. 7 is the largest when compared to the previous values because there are no previous values for 0th index. For first index, you could see 4. You need to compare 4 with 7. But it is not larger than 7, so 4 can't be valid. So for first index, I need to check index numbers. So let us write here separately the check indexes. 0 index need to be checked. For second index, we need to check 0 as well as first index. So which means we need to compare 2 with 4. Well, 2 is not larger than 4. So 2 is not a valid one. Well, actually it is not 2. It is 8 by 2. So on that case, it would be like this. 7, 4, 8, 2, 9. So for second index, you could see 8 is greater than 4, 8 is greater than 7. 8 is greater than 4 as well as 8 is less than 7. So it is a valid one. For the next value, which is at third index, I need to compare it with 0th, first, and then second. So which is 2, it is greater than 8, so it's not a valid. Fine. For the fourth index, I need to compare index numbers 0 1, 2, 3. Well, 9 greater than 2, 9 greater than 9 greater than 4, and 9 greater than 7. So 9 is greater than all of its previous elements, and the answer, I mean, it's valid one. So how many answers or how many larger previous value? 1 and 3. So the answer is 3. So we need to write an equivalent code. So for writing an equivalent code, so to write an equivalent code, the challenging part is what would be your algorithm? Because for each every element, you revisit each and every previous elements. That is one way to work on it. For example, for any index, if it's number 10, you need to visit indexes from 0 till 9. For index number 20, you need you, you need yeah, if you take 20, you need to visit indexes from 0 till 90. So for each every index, we need to visit the indexes from 0 till its previous indexes. That is one way to work. So it will be like this. Let me show it in an Excel sheet. So this is the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 9, 10, 11, 13, 14. So while working for index number 0, no one for need no need for visit anyone. For working for index number 1, we need to visit 0 index. For 2, we need to visit 0 and 1. For 3, we need to visit 0 and 2. For 4, to visit 0, 1, 3. To update it for 5, we need to visit 0, 1, 2, 3. Well, it goes on till 14. For 14, I need to visit total 30. So how do we save some time from this? Is very simple. Because the time complexity of this particular should be equal to n square, but it would be done in O of n. So how it could be done O of n? Let me write sample for you. Other than the given sample, let us come up with some extra samples. 2, sorry, 10, 3, 12, 9, 6, 15, 20, 70. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I have 10 elements and the indexes of it. So let us see what are the valid values, right? So then it the answer. 7, it is not. 3, it is not. And what is the next one? 12. Next one is 12. 11. Take and work for 11. 12 is not less than 11, and so it's not a valid one. Comes to 9, it's not a valid one. When it comes to 6, it is also not a valid one. Comes to 15, 15 is a valid one. Right? 15 would be a valid one because 15 is larger than all of its previous values. When it comes to 20, 20 is a valid one. 20 is larger than all of its previous values. When it comes to 17, 17 is not a valid one because 17 is not other than the previous values. Now you could see these things. What is it? The valid values. If you see those valid values, you will get a pattern of it. Well, 10, 12, 15, 20. How these are there? These are in increasing order. So the first max is 10. When you see someone larger than 10, that would be the max. When you see someone larger than 12, that would be the next valid value. When you see someone larger than 15, that would be the next larger value. Or next, that would be next valid value. So what be final conclusion? Start the first element. Start with first element as max. So my first one would be the maximum. So what am I supposed to do further? I need to move from first element till the last element of the array. When moving so, the basic task requires I need to find is there any larger than. Why does it works? Because the condition says an element can be counted if it is larger than its previous values. Until you meet 3, the previous largest value so far 10. So if you have found someone who is larger than 10, it would be the largest, or it would satisfy the scenario case. If you just take 11, 11 is larger than 10, but it is not less than 12. So obviously 11 can't be a valid. If you take 9, the same story, same story. But when it comes to 15, 15 is larger than the previous max. What was the previous max so far? Previous max so far is 12. What about 20? 20 is larger than the previous max. So start first element as max. If anyone is larger than max, count and update as new max. This will be the logic. Or to make simple, you know what this problem statement is about? Finding the largest element in an array. Finding so, what will be our basic? We will come each and every element with the previous max. And you could see what will be the answer. The answer is number of maximum updations. For example, let me show you. Uh, I will give you a one demo. Well, with this particular demo, we will discussion. I will write an code for it. Write 3, 4, 6, 7, 8, 9, 10. Done. The values in this array is hidden. Okay, we don't. Mm, just, yes, I want to find out the maximum value out of this array. You you know the value inside the array. We will be seeing one value at a time. So let us see first value inside the array. Let me show you. What is the first value? 16. If I ask you what is the maximum, you say 16. Because you have seen 16 so far. You haven't seen anything other than 16. So your answer is 16. Now you will see the second value. What's the second value? 12. And if I ask you who is the maximum, you would say 12. Because, sorry, not 12, it's 16. Because the previous max is 16, you haven't seen anyone larger than 16. Now, third value. What's the third value? 18. On seeing 18, what you do? You would compare 18 with the previous max you got earlier, which is 16. Well, 18 is larger than 16. And so you would say your output is 18. because 18 is larger than the previous max. Let me continue it. 13. No, I don't want. It's not larger. 11. I don't need. 7. It's not larger than 18. 40. Well, 40 is larger than 18. Now you remember 40 and you won't worry about 18 because 40 is larger than the previous max. So you see 16 you remember. The next value you updated was 18. Now this value you updated was 40. And what's next? Next element says 25. Well, 25 is not larger than 40. Let me skip it. 1 is not larger than 40. I would skip it. And the finally value is 70. Well, 70 is larger than 40. You would update 70. Now if I ask you who is the maximum value in this particular array, you say 70. What was our problem statement? Our problem statement is find out the values in an array who are larger than its previous values. Actually, the basic logic required is finding maximum in an array. Whenever you're gonna update the maximum value, those values would be larger than the previous values. Take 16, 16 is larger than all of its previous. About 18, same. 8 is larger than all of its previous value. What about 40? 40 is larger than all of its previous value. So on hitting 40, you would update 40 as the maximum. Well, on hitting 70, you update 70 as the maximum because 70 is larger than all of its previous value. So all you're supposed to do is traverse the array, compare, and find max. Whenever you update max, whenever max is submitted, have a counter variable. First is first value. Then on meeting the next maximum value, update the count as 2. Then on meeting the next maximum value, update the count as 3. Then meeting the next maximum value, update the count as 4. So finally, the answer would be 4. So that is it. Let's write the even code for it. So into the coding part. So let us do the sample given. Let us do the given sample array, which is integer array of 7, 4, 8, 2, 9. And the number of elements. So first, as I said, right, very simple question. If they have asked, find out the maximum element in an array and update the number of count of max elements, it would be much more easier. But they have asked in that particular way. The question has been framed in such a way which we have addressed it, right? Do not waste time in repeating. What am I supposed to do? I need to traverse the array from index till number of elements. For each every traversal, I need to compare the array element, or I need to check that the element is a larger value than the max. If it is so, I would update this. This is the code for finding maximum element in array, and the default maximum value would be the zeroth index. element, which is the first element of the array. So our problem statement is it's not about fitting the max alone. We need to get to know the number of updations of max. So let me have a result counter. The initial result counter would be 1. This is for 0th index. From first index, I would come. Whenever I update and max, do count it. Result counter plus plus. And so finally, you could put the count of the result counter, which should be the result. So for this particular array, the output should be 3. So here it's index and number of elements. Let's check whether it works or not. So it says it should say 3. Yeah, we are getting it right. So the first question is a very, very simple question, dears. Second question we would work on a little challenging one. Challenging in terms of it will also be a simpler one, but we need to take a little extra effort to find out the crux of to be done. So done with the first problem statement. This is the code. Will I have declared that array in a static rather than a static declaration? Let us rewrite the code in a dynamic way. So the first content should be reading the number of elements. So scanf percentage number of elements. Once the number of elements is read, to by for an array. So in the array of number of elements. Once we have bought memory, we need to read put. So to reading process, we would use the help of scanf. So scanf %d comma address of array of index. So our code now would work dynamically for varying index. So here index is declared. Let us declare index above what is being used. So let's sample which we worked over here. This output should be for 16 elements, right? 1, 2, 3, 4, 5, 9 elements. So the number of elements is 9. 16, 12, 18, 13, 11. 16, 12, 18, 15, 11, 7, 40, 25, 1, 70. So output should be 4. Well, it says 3. Mistake 16, 18, 40, 70. It should not be 3. It should be 4. 3, 4, 5. So the mistake is 1, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, actually the length of the array is not 10, it's 10. So let's rerun it. Now let me give number of elements as 10. Same input, output is 4. Yes, it's working good. Understood, dears? Please do reply in chat whether you got an idea. If we would proceed for the next question, it should be an important one, quite challenging one as well. So the chat is enabled. You could share comments, say yes or a thumbs up. So traverse the array and find out the max find the max just the number of updations. If we do so, the expected output is. So anyone drop late, this is the problem statement. If you want, you could read it. We'll have a glance at it. Fine. So let me share the next question. This is easy level question. The next one is it won't be as easy as this one. Interesting one. Here it comes. So do read it properly. They got a brief explanation on what's need to be done on each and every step. Just take your own sweet time. So we got two experiments, one for the sample which has been had in the problem statement. The other one is below. That is the sample explanation. I could see the problem statement in the first itself, but before that, I want you to read. We'll give it a try. This the same question has been asked earlier with a different story. Here it says a sports teacher is there and the students has the jersey number. This is the way the problem statement has been named. There was in one other interview talks where the same question is being framed in with a different story called grooving monkeys. Yes, hope so. You have read it. Well, since it's an online session, I cannot give you sufficient time. So if needed, you could pause this video. Will take your own sweet time. Take 10 15 minutes. Work on it. Give you 100%, and then continue with this video so that you could have it yourself how thought how does it works. So let's explain the problem statement. So to start with, Jack is a sports teacher at St. Patrick's School. These are all backgrounds stories. Hmm. He not only to make students fit but also smart. So he lined up all n number of students in the class. At each position, he fixed a board with integer number printed on it. So what does it says is he got a fixed board with a number on each and every position. Each of the number are unique and exactly in the range of n. So it will be unique and which will be exactly in the range of n. Also, all the students will wear a jersey with the number printed on it. So, what about the number and so students with the number? So, there are two numbers. One is one, which is like the board. Other one is number printed on the jersey of the student. Each student will have a jersey number. So, jersey number also is unique. As the board number is unique from range of 1 till n, the jersey number also will be unique. Now, in the meaning, all students will stand in increasing order of their jersey numbers from left to right. So at start, the numbers would be in a such way until n. That is the jersey numbers. That is the way they be stand aligned or assembled. The one difference is their respective board numbers, which is placed at their respective location. As I said earlier, the board location is fixed. It cannot be changed. We can consider the arrangement as below. Suppose the five students and the board is placed in the order of 2, 3, 1, 5. Students just 1, 2, 3, 4, 5. You could see line it is 2, 3, 1, 5, 4. In the second line it is 1, 2, 3, 4. So the first line is the board, which is going to be a fixed one, which won't change at any point of time. The second line would be the student's jersey, which would change according to the time. Right, yes. Now the game begins. After every beat of the drum. So for every beat of drum, what are we supposed to do? That's the important point. So let's read further. Each student has to, for every beat of the drum, each student have to move to that location where this particular board is pointing to. So the students would keep on moving, and a student would move in such a way based on the board number. So based on the board number, the student would move. So the board number is something which is pointing towards a particular location. And the students are supposed to move according to the number. Right? In the above case, student with C1 is standing with board number 2, so he will move to the location. Similarly, all other students will do. So after the first beat of the drum, the alignment of the board would be 23154. So there's no change. What has been changed? The student jersey is changed. The student's jersey is changed in a such a way 31254. Okay, so this is one important area. They have explained the first step, but the first step is not explained in a brief. So, what is the only best for us to do is take a notebook, have a pen and paper, we'll write and see. So, with the help of a pen and a paper, I mean that is notebook, we could do a lot. Let me explain it in that way. It will be easy for you to what could be done. This is board 2, 3, 5, 1, 4. If I am not right, yes, 2, 3, 1. This is my board. It would be a fixed one. It won't change during the entire course. It will be fixed. This is student's jersey. This is positions. 1, 2, 3, 4, 5. So student's jersey with the jersey number. Yeah, fine. So this is the initial 1, 2, 3, 4, 5. So what do they say? So is each and every student at a particular person will move to the value pointed by the board. So each student will move to the place pointed by board. Board. This is a very, very important point. Each student will move to the place pointed by the board. Take the first student. Where he should go? He should go to second. Board says 2. So person number 1 should go to the second place. Second place. And the person who is standing second position, or else say each student at a respect position will move to the place of position. Let me cut it and paste it below. Yes. Fine. Because what I'm concentrating on this particular point is that is the end algorithm which needs to be concentrated. So it seems like a simple question there, but got a lot of optimization in it. It's not the basic solutions we're gonna concentrate. So let's see what are. So person number 1. Why is it so? If you want, mark it for you. 1 goes to second place. So 1, the first person, I mean person standing at first position, will see the board which is 2, and he will go to the second place. So what happens to the second place? It will be updated as 1. I will show you the arrow mark alone. Now, what's next? The person at second place, the position should go down to who is at second place? Student with the jersey number 2. So he will to the third place. That is position number 3. So this is what happens. On next point. Position 3, each student at a respective position. Now, student standing at position 3 should check the board. Board says 1. So the student standing at third position will go to particular one. So to have a clarity, you may be a bit confused between the value and the student. So let me ask student 1, student with number 2, student with number 3, student with number 4, student number 5. Student 1 at second position, student 2 at third position. Now student 3 is at position, will see the board value which is 1, and that respective person go to the first position. So student 3 will go to the first position. See the position and see the board numbers. Move the value from that particular position to value pointed by the board. What's next? Position 4, student number 4. In position 4, S4, student 4 standing. Where he should go or should go, that respective person should go to the board is pointing towards fifth location. So yes, as well as the next one. The person who is standing at fifth position, the board pointing is to the fourth place. So the person or the student at fifth position should go to the fourth place. Plus 5 will come here. So this is what happens at end of step number 1. So this is the first step. Now let us see what the problem is. In our problem statement, again for the second beat of drum change, the places change, and it keeps on continuing. This keeps on going on and on until all students are back where they were at the beginning. So it needs to be repeated unless and until those persons come back to their original places where they are at the first scenario. So the answer says after 6 beats, all of them would come back to their original place. Let us check, is 6 the right answer or not? Those whoever got little doubts regarding what we have earlier, you would get it clarified in the next step. So this is at end of step number 1. Now step number 2. Same story. Well, what's the story? Each student at a respective place. In the place or position 1, who is there? Student B is standing. In the place 1, student B is standing. So the place 1 student should go to the book value, which is second place. So what happens? S3, student 3, who is at first position, go to second place. S3. Student 3, who is at first position, go to second place. This is what we done. Again, student 1, who is at second place, go to third position. So student 1. Now student 2 is at third place, go to first place. So what happens? Student 2 will come to first place. Now student 5, who is at fourth place, to fifth place. So student 5 will go to fifth place. Now the same story for student 4. So student 4, who at fifth place, go to fourth place, which is entered by the board. So student 4 will come to fourth place. If you saw the updated value, last two values, who student 4 and 5 back to their original place. Student 4 at fourth place, student 5 at fifth place. But what was the problem statement says? Expecting all students getting back to their places. The expected thing is all of them should be back to their places. It's not two persons alone. It means step number 2 is not final step. We need to proceed further. Well, what's the next step? The same story. If you want me to repeat, this is what happens. Student 2, who is at, student 2 is at first place to second. So it means what would happen? Student 2 will come to the second place. Now again, what's the next step? Student 3, who is at second place, go to third place. So it would be S3 at place. Now next step for the question. Student 1, who is at third position, should go to first place. Yeah. Now student 4, who is at fourth position, go to fifth place. Finally, student 5. For the next time, I won't be drawing these, so I will just fill out the values. So this will be the explanation for how the value move. Right. Student 5 with that fifth question should go to fourth place. And this is the output. And you could see here, in the current state, 1, 2, 3 are back to places. Yeah, here it is student 5 and student 4. I made a mistake. 1 to 3 are at places, but 4 and 5 are not. It means it's not expected output. We need to repeat it on repeating it further. Because what was the expected output? We repeat it unless all students back to their places. In the step number 2, it was partially. In step number 3, it was partially. I will make it a complete one. So what happens if you repeat further in the very step? It would be like this. Yes, 3. Well then, 1. Well then, yes, 2. Yes, 4. Yes, 5. This again, partial. Now step number 5. Yes, 2. 3. Yes. Yes, 5. Yes, 4. It is not back to their places. In step number 6, it will be S1, S2, S3, S4, S5. So you could see all students will be back to their places on the 6th step. And that is the reason the output of this problem state is 6. 6. So whatever we have done and discussed manually, it will be written as equivalent code. Each and every time have an array where the help of the values, and you could move the values accordingly. So that at which particular the values such that comes to 1, comes to 2, 3 comes to third place, 4 comes to fourth place, and 5 comes to fifth place, you could count steps and you could say the answer. That would be a basic solution. But the challenge part is the time constraint, or to be they mentioned the time constraint precisely, but you could see the number of elements here. So for this particular problem statement, number of elements would be 10 to the power of 1 to 5. If you got have 10 power 5 elements in an array and you want to implement this particular approach, for sure a lot of time would be wasted. Doesn't mean it can't be done. It 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 find the solution, no doubt about it. But the challenging would be execution time. So we need to come with a better idea for. So what is a better idea mean? We need to keep track of the number of steps in which we need to find an approach. The number of steps could be calculated. So how to find so? Simplify it. See the problem statement in a much more simpler way. Understand what needs to be done. In the screen itself, you could see in this particular sample, there are 5%. But you see the change in places are occurring in two different groups. Person number 1 to 3 are interchanging their places, as well as 4 and 5 are interchanging their places. And this is a particular group. I would call it a group 1. They are interchanging the places among themselves. Quite the same. This is another where they are interchanging their places between those two values, which is 4 and. So, with the help of this, you may get an idea. Well, what is this color scenario? when those persons are back to their place. Just see the 4 and 5. The 4 and 3 are back to places at each and every 2 steps. Am I right? In 3, 4, 5, 5, 5, 4, second 4, 5. Then again 5, 4, 5. Then again 5, 4, 4, 5. For the person of group 2, they are coming to their places at each and every 2 steps. For a person of group 3, they are back to the places at each and every 3 steps. Yes, 1, 2, 3, 3, 1, 2, 3, 1, again 1, 2, 3. Then 3, 1, 2, 2, 3, 1, 1, 3. There are persons interchanging or like moving among themselves. They will be back to their place at end of the third step. If there are 2 persons, they are back to their places at end of the second step. Well, to put it in very simple words, dears, imagine there are persons standing in circular form, right? Uh, Let it be. Uh, 1, 2, 3, 4. So in the first step, let us imagine on a jump to their immediate right side places or left side places. Each and every person will move towards right, the immediate right, or the, for example, over here it will to the left. Step number 1, once 1 will go to 2. Am I right? 1 go to the place of 2, 2 will go to the place of 3, will go to the place of 4, will come back to the place of. This is what happens at step number 1. At step number 2, you could see this would be the updated value. 4 will go to the place number 1, 1 will go to the place of 2, 2, sorry, uh, here it is 2, it is 3. Now, step number 3. So, if you see the step number 3, this would be the output. Let me zoom in. 1, 2, 3, 4. And in the next step, which is step number 4, it will be 1, 2, 3, 4 again for the output. So when there are 4 persons who are moving in a circular fashion, they will be back to their places at end of step. It's quite a very basic logic, right? You just play with your friends or the way we have played in our good days. So we will be back to the start place at end of the step, which is be based on the number of persons. So if people are counted in a circular fashion, if they move one step at a time to the adjacent person's place, they will be back to their place based on number of persons over. Quite the same law is being done over here. Well, let me show to you. So there are 4 persons. 2, 3, 4. They gonna exchange their interchange. They would be moving places among themselves. So, for example, the first person will go to third place, second person will go to first place, third person will go to fourth place, fourth person will go to second place. These are go-to places, which we call it as board values. In our example, what I have discussed, wrote 1, 2, 3, 4. 1 go to 2, 2 go to 3, 3 go to 4, 4 go to 1. This is the was circularly connected. But what was our problem statement says? 1 go to 3. 1 should go to third person space, and third person will go to fourth person's place. Fourth person go to second person's place, and second person will go to first person's place. It is also moving in a circular form, but the numbers are the places are not in linear order. I'll be precise. In a circular way, the places where I'm going in an increasing order. I'll be precise. The very next number. What was our in problem statement 3? Well, there are places 1, 2, 3. These are values. The red color one, dears. Let me mark it out because I want you to understand the core thing behind it. Yeah, you go. 1 go to 3. 1 will go to 3. Well, what about 3? 3 will go to 4. 4. What about 4? 4 will go to 2. What about 2 will go to 1? Let me write in a proper design. So 1 will go to 3, 3 will go to 4, 4 will go to 2, 2 will go to 1. It means it forms a loop. You could see the same circle, but the same circle. Why is it the same? It's why it's called circular one. The starting point and the ending point are same. You see, it's the starting point and ending point are same. It doesn't seems to be in a circle shape, but the flow, the way how person moves are in a circular order. Circular order, I 1 going to 3, 3 going to 4, 4 going to 2, 2 going to 1, 1 to 3, 3 to 4, 4 to 2, 2 to 1. First to third place to fourth place, fourth place to second place to first place. So instead of the basic thing, which is easy for you to understand, right? 2, 3, 4. The demonstrated earlier was 2, 2, 2, 2, 3, 3, 4, 2, 1. This is also circular. 1, 2, 3, 3, 2, 4, 2, 2, 2, 2, 1. Also circular. Both are circular. If there are 4 persons, in how many steps they will reach? In 4 steps they will reach. If there are 5 persons interchanging their places, so they would reach in 5 steps. If there are 7 persons interchanging their places among themselves, they would reach it in 7 steps. Well, if you want a proof, let's do it here. Now 3, 1, 2, right? Well, what happened? The person at 3, this person. So student 1, student 2, student 3, student 4. So student 1 go to third position. Okay. Student 2 go to first position. Okay. Student 3 go to fifth position. Student 4 go to second position. Done. This is at end of step number 1. Now step number 2. In step number 2, student go to third position, which is S2. Student 2 go to first position, which is S4. Student 3 go to fourth position, which is S1. Student 4 go to second position, which is S3. Now in 3, student 1 go to third position, which is 4. Student 2 to first position, which is student. The student at third position go to fourth place, which is student 2. Student at second, well, I got a bit confused. Yeah, fine. Let me talk up. Uh, the student at first position go to third position, yes, 4. Student at second position go to first position, which is student. Student at third position go to fourth, which is you. And student at fourth position, which is S1, go to second place, which is S1. Now, on fourth step, as I said, there are 4 persons interchanging their place. We would get the person should come back to their original places, and you could see the student first position should go to third place. At first position, S3 will go to place. Student at second position should go to first place. Who is at second position? Student 1 will come to first place. Student at third position will go to fourth place. Who is at student at fourth position? S4. S4 will go to fourth place. Student fourth position go to second place. Who is at fourth position? S2. And you see it's done. So four people are when n people interchange their places, it they will come back to their place at n step. That's the way of the first analysis. When n students interchange their places, they will come back to their original place by n steps. So this is the first takeaway. If there are n students interchanging their places, they will be back to their place in n steps. So now comes the final conclusion. The sample which we were working was this. Here there are five students. Even though there are 5 students, you need to take a note of it. Yes, you could see there are 5 students. Since it is students, we can't blindly say 5 students will come back to their places at 5 steps. The reason is the number of students is 5. How many of them are interchanging their places? 1, 2, 3 belongs to a group, and 4, 5 belongs to another group. So as per my earlier conclusion, this is group 1. This is group 1. This is group 2. So group 1 got how many steps? 3 steps. Group 2 got 2 persons. So group 1 will be back to their places at 3rd step, 6th step, 9th step, 12th step, and 15th step. It's on. Group 2 will be back to their places at 2nd step, 4th step, 6th step, 8th step, 10th step, 12th step, and so on. If you proof, you could see that is what we have later. Number 1, 2, 1. They are back to their places at step number 3 as well as number 6. Group number 2, which got 2 students, they are back to their places at it end each and every 2 steps. Step 2, step 4, and step 6. When are we supposed to stop? In both of their step matches, we need to stop, which is group 1 and group 2 have the first common value, that is 6. Well, actually, it would show you more samples, so it would be better to find the answer. Now, as of like, okay, fine. I would give. We will. I would show the step up for one more sample as well, so that we could make a, better conclusion of it. So, what's this here? This is my. So 1, 3, 4, 5, 6, 7. Let these 4 points interchange their place. So these are the board values. These are the positions. Now, how many persons belong to this particular board? These 4 persons belongs to group number 1. These persons belong to group number 2. So group number got how many persons? It got 4 persons. Group 2 got 3 persons. So it's a group got 4 persons. In group 2, 3 persons are exchanging their places. So when it comes to 1 and when it comes to 2, so when does they would come back to their places? At fourth step, group 1 will come back to their original place. At third step, group 2 will come. So this is group, this is group. Fine. Then now what I'm supposed to find? I need to find out the step number on which all the groups, it may not be always 2 groups, yes, it could be any number of groups. To find out the step number where all persons come to their original place. Let me extend. In 8th step, group 1 will be back to their place. In 6th step, group 2 will be back to its place. In 10th step, group 1 will be back to its place. In 9th step, group 2 will be back to its place. In 16th step, group 1 will be again back to its place. And what about group 2? Which step number? 3, 6, 9. And what's the next thing? 12. And you could see we found out a common step number. If you continue so, you may find some other common step numbers as well. 15, 18, 21, 24, 27. You could see the next common step number 24. So here 6 and 6 common, 12 and 12 common. But what is the answer? 6 is the answer. 12 and 12 common, 24, 24 common. So here also we need to find the common values. We need to find the common values over here as well. And what's the specialty of the common values? Whom we are preferring? We are preferring which value out of 6, 12, 18, and so we prefer 6. Out of 12, 24, 36, and so we prefer 12. How the common value highlighted? Common value, that should be what? The largest or the smallest. So it's the least common value. What do you mean by least common value? LCM. Problem statement says finding LCM for the size of the groups in the given input array. If you go for 2 to 3 more samples, it will be very hard to say yes, it is LCM. Here I am just conveying with the help of two samples alone. 4 and LCM of 3 is 12. And so at 12th step, it would be everyone will come to their 3 and 2. 3 twos, I mean not 3 twos. The LCM of 3 comma 2 is 6. And of 6th is those persons will be back to their places. So what our only task left out in our coding part, we need to find out the size of each and every group inside the gen view. That's the first task. What if you know the size of the group? Based on the different group size, you could calculate the LCM. So LCM is the core task. As you see the problem statement, it is not being shared in any line of problem statement. You need to LCM. So that's the reason we work on this particular sample. Once the sample is worked out, we are able to see what needs to be done. So yeah, now comes the final point. Well, which how do we identify the group size? One, it's done. Because to make it simple, I'm continuously choosing the group elements. Well, what this is also a valid input, right? For example, so 3, 7, 5. Sorry about it. You place here it comes. So it's in B. So here you could see these three persons belong to a group, and 6523. These four persons belong to another group. This is also group of 3 as well as group of 4. Fine. So the final task, the task number, because we know the final task. The final task is finding LCM for the sizes of the groups. Or what I would say is, first task should be identify the group. Well, how do I identify the group? It's simple. So let me take this particular sample itself. So identify a group is an easy task. Let me uncolor so you would what needs to be done. So how do I work on it? Is I would work for index number 1. Right. Let us assume the position as index of the array. Go to index number. What is the value inside it? 4. Go to the fourth index. What is the value inside it? 7. Go to the seventh index. What is the value inside? 1. Go to first index. 1. I came back to the place where I have started. So you would start with a particular index, you will keep on moving, or I would update the index, by value of that index, value pointed by that index. Repeat it so, and you count it. Well, what would be the count? I started from, then I moved on to 4, 2, moved on to 7. So totally how many jumps? 3 jumps. So 3 jumps, the size of the group 3. As like starting from 1, then I start from 2. Well, you could see 2, you will go to, well, let me show you. Let me mark it in a different. So if you start from 2, 6, go 6. This is step number 1. 6 to 3, step number 2. In third index, the value is 5 to 5, step number 3. In 5 index, it's 2 again. So you will go to 2, which is number 4. Well, is there any need for you to repeat further? No need. So you could have one more array called visited array. If any index in visited here, you could avoid visiting. You could avoid visiting it further. Or else you could say if all elements have been visited during the splitting process, you could stop counting group size further. So let me write an equivalent code. Just taking one step at a time will do a lot. So let me start first. So what is the equivalent code? I would start index 1. Right? Yes, my start index is 1. What am I supposed to do? I need to fetch the value from the start index. So array of start index. Okay. Well, what am I supposed to do? I need to update the start index by the value. Update the index value by the value pointed by the index. For each every updation, you count it. Count plus plus. Will repeat this process unless until the start index, I mean, unless until you come back to the initial starting index. So, or else you could say if I need to remember the start index, right? So I need to have a variable called safe. So safe equal to start position. So if start index or moving index is equal to the start position, we may stop it, break. That is it. Well, actually, I need to choose a proper variable name. This is one thing I would follow always. Here, the start index seems a bit confusing. Why is it so? One variable is called a start index. The other one is called start position. That's not good to keep. So what I say is, say group start. So the group is 1, and I would call it as the moving index. So the moving index will start group start index. I would update value from the array of move index. Each and every time my moving index updated, and when I would stop my moving index, come back to the start of group. you could take it. So this will be the code. For each every time we are counting, so the counter will be the size of group. So instead of counter, we make it as groups plus plus, which has more meaning, right? So let us do right code. So fine, a new file. So for finding LCM, I would be an optimized approach, but I will be discussing in brief about it. If you want, just learn. I would just conclude with respect to this particular problem here. So in well, what be the inputs? Yeah, the input would be board values. Fine. Integer number of elements. Scanf. Well, same story, right? Why don't you copy paste it? So the array is instead of array, we get it as board. The board value is fixed, right? Board. So let me write a function called find group size. Or else you could write it code all by itself. Group start index equal to 1. We may buy one memory extra and you make use of the index from 1 till number of elements. We would avoid the x number 0 because the contains it's one indexed integer. So I would just maintain index from 1. Group start index is 1. So what is my task? Need a moving index. So integer a go to index or move index. Go to index equal to group start index. Well, what's the step number 1? Value is equal to of go to index. Whatever the value pointed by the go to index, that would be my next go to index. I would have wrote it in a single line. If you want to write it in a single line code, it would be go to index is equal to code of value pointed by go to index. That would be a single line code. But to have a clarity, I am just wrote it in a two line. I am declaring a variable called value and then I'm storing it inside the go index. For each and every time, I need to increment the count of the group counter plus plus. And I need to repeat this process. So what will be the initial value of group counter? Initial value of group counter will be 0. So while of 1. Let us print the group counter value. And when I should stop, the go index is becomes the group start index. If the go to index and index are same, you came back to the same position where it is started. This is the crux of the code, main crux of the code. This is it. So go to index starts from a group start index. The initial group count is 0, and I would update the go to index for each and every step by increment the count of the group. When it goes back to the original position, I would stop and I would print the count of the group. Let us do run check whether we are getting it right. So number of elements 2, 3, 1, 5, 4. So the size of first group is 3. Since we have worked for only index number 1, it belongs to the element collected to index number 1. So which is 2, 1. The group should say 3. Let's check. Yes, we are getting 3. Super. Now let me check with particular sample. 4, 6. Here are 7 elements. 4, 6, 5, 7, 2, 3, 1. So over here, 4, 1, 7 are connected. The size of the first group should be 3. This also should say 3. We could see it says 3. In our code, let's pass the same input. Instead of pass 4 as, first index as the start value, let us pass second index as the start value. It means 6, 5, 2, and 3 are connected. If it go, it should say the group size as 4. So I am manually making it as 2. The group start index is 2. I have started my group start as second index, third index, fifth index, and sixth index are connected. So it should say groups as 4. And it is working fine. Well, to repeat it, what am I supposed to do? Enclose this code snippet in loop. You could see this was the task which we have done. I'm just doing it inside a block, and I'm varying the group start index from 1 till number of elements for each and every time. So group start index less than number of elements, group start index plus.